Good evening. My name is Rich, and I'm a principal software engineer here at King. I've been at King for about 5.5 years now, so pretty much an old timer in terms of King. And I'm sure most of you know King is pretty well known for its games. I'm not sure how many of you have played any of these up here, but I'm sure there's a few closet Candy Crush franchise friends. So here's Soda Saga, which is obviously pretty much what we're best known for. But I want to take you beyond that, and beyond games at King, and talk about fraud. And it may not affect King in the way that you think it does. And it is actually a $1 billion issue. In fact, last year it was estimated that fraud cost the advertising industry $19 billion. So it's quite a large problem and quite important that we get it right. So when I think about fraud, this is kind of what I think about. I maybe think about identity theft, or people hacking into your account, stealing your credit cards. But that's not really what it is for King. We don't care about the people that cheat at Candy Crush. We don't care about the people that fake Goldberg purchases. We don't care about people that boost profiles. Because really, if you cheat at a Candy Crush level, you're cheating yourself. You're comparing to your friends, yeah, okay, I'm the final level, no one cares. Faking gold bar purchases. Now, I guess this is kind of more serious. You're kind of faking money. But all of our real purchases go through the App Store. And so that's all verified and legitimate. And so it's not really something that's going to cost us money. And then finally, with boosting profiles, we're not World of Warcraft. People aren't selling custom Candy Crush level achieved on the black market. It's just not something we really care about. So fraud for us is any attribution attempt that does not conform to an agreed set of principles, which would be genuine, timely, and relevant. And I realise that I've just spoken about this, but I haven't really explained what attribution is. And I know this is supposed to be a technical talk, so I'm going to try and do mobile attribution 101 with the technical bits in it as well, to give you some context on how fraud affects attribution. So attribution is the process by which an advert, an impression on an advert, or a click on an advert is consolidated with an install. So you may be presented with an ad on one of your apps, and you click it, you go through to the App Store, you install the game, and that's an install. And that's what we would count at King. Once you've opened the game, that's what we count as an install. But to look at how that works at a kind of an event tracking level, so we have our click, which goes into our tracking service, and that's just a simple HTTP call. It hits one of our tracking servers, which is load balanced, and then it just does a simple 302 redirect, and then you end up magically in the App Store, and it should be seamless. You should never really know that you've gone and hit one of our servers at all. The user will install, and then they'll open the app, and then we'll get the install notification come back to us, and then we're able to try and start this process of attribution. Now, the thing that really kind of helps us in this whole process is Kafka. And I'm not sure how many out here are familiar with Kafka, but it's effectively, it's a streaming platform. It's a message bus, if you like, and it allows you to put your events or your messages onto a topic where you can consume them from later. And so now we've got our messages and they're ready to be dealt with. But how many messages are we talking about? So I think it was for yesterday I ran the numbers, and we dealt with about 95 million clicks and impressions, which is about 1,000 a second, which is some decent load. And when you couple that with a lot of the other game events that we have to process, it runs into the billions of events that are running through our tracking system. And so in order to cope with this, we have our topic, but it's split into partitions. And the way Kafka works is that you have partitions, and you can put data based on a partition key onto different partitions. It flows into our attribution service, and then if it's a click, it's added into our database, which is just a simple MySQL database. And if it's an install, it checks against that database to see if there are any matches. But of course, in reality, nothing's ever that simple. So topics can only have one consumer. So actually, for each topic, you can only have one thread reading from it. Sorry, for each partition, you can only have one thread reading from it. And so then you need to have your threads put that in, well, what we do is we put it in a blocking queue, and then we have a thread pool reading from that blocking queue, and then you can utilize the full power of the server that it's running on. We also shard our database in order to reduce lookup time and also increase resilience. And what happens is your click will be hashed and the shard will be chosen and it will be placed in there. And then when you come to look it up with the install, you know which shard you've got to look in, and then you retrieve the data. The interesting thing about this is that we're not talking just about this 95 million clicks that we want to put in our database. At this point, it's split into different identifiers. So there might be a fingerprint of the device you're using, or an advertising ID, or maybe a referrer or something. So that gets broken down and put in different shards, and then stored for 28 days. So suddenly our 95 million events goes up to over 50 billion. And so our database is now storing over 50 billion events, and we need fast access to that data. And so with the use of indexes, you actually can get some really good performance out of MySQL, and it's a very good multi-purpose database. So simplifying it all down again. So we have our topic, we have our attribution service, we've got a click and our installs. And I just wanted to give you like a little lesson learned here, because I'm sure you're thinking, oh, hey, you've got a lot of concurrency going on. You've got a lot of threading there. You're putting a lot of data in databases. How do you make sure that concurrency is an issue? And the clicks, well, we're adding the clicks, and the clicks just accumulate. And we don't care about if there's 2 clicks that come in at the same time. They'll just be added to the database, no problem. And we don't care about the installs either, because when we go to insert it into the database, we're going to add it, and we're going to check that there's not one there that exists already, and it's going to be magic, and it's all going to work. Because we'll only ever get one install per device. But that's where you're wrong, because you can never trust your clients. We learned this really recently, I think just last week. And I've been here 5.5 years, as I said, and this is the first time this has ever happened in 5.5 years. And suddenly, we can't trust our clients. So one of our very small games, Candy Crush, like the biggest game, decided to start sending us 2 install events. 2 install events. For every 1 install, 2 install events. But now you don't know what to trust. What do you do? And so he's going to add these 2 install events into the database. We're going to get double attribution, or 2 matches, which isn't good. And yeah, again, you can never trust your clients. What we should have done, and what we have done now, is we've put a lightweight cache across the database access call. So you add in a reference into a concurrent hash map. There's a semaphore there which you acquire and lock, and that means that no one else can add something into the database while you're not looking. And it's very simple, but now it works. So yeah, lesson 1, never trust your clients. And so the purpose of all this, and where really the fraud journey begins, is with the attribution. So we've come out of we've checked for our install, we've found a bunch of matches. Someone might have clicked on a couple of ads by mistake, someone may have watched a few videos. These are all things that we would consider a match. And now we've got our attribution, like processing to do. And so we go through various filters. And all of these, again, tie into the genuine, timely, relevant theme that we're looking for. So is it a valid network? Is it a valid game? Is it inside the bounds of an attribution window? Maybe we only want to look at things that matched from yesterday, not from like the last 5 minutes or from the last 7 years. We only care about stuff that happened yesterday. The strength of the match. Are we using a probabilistic matching methodology or a deterministic one? And what's the relevance of that when you're looking at a click versus an impression, and which one's a stronger hint of someone wanting to install? But none of these things we would really consider fraud. These are just irrelevant data. So we filter all of that out, and then we're left with a very small number of potential attributions that we will want to dig into a bit deeper. So then we go back to the $1 billion problem. Where's fraud happening in this flow? And to do this, I'll talk about a few different types of fraud and what they mean. So the really three main categories of fraud which is affecting the market at the moment. The first one is click spam. And the second one is click injection. And then we have device spoofing and emulation. With click spamming, what's happening is it's a real user. They've gone to install Candy Crush, but actually a fraudster is just going to spam your service, your tracking service, with fake data. Loads of clicks that haven't come from anyone real. Maybe they'll send 100 for your device. They send one for your device every single day until you end up installing Candy Crush, and then as if by magic, they get the attribution. And you think, how is this a billion-dollar problem? Well, for every single attribution or for every single click, they're going to get paid. For anyone they drive into our games, they're getting some form of revenue. And if they weren't really showing an ad for that user, then that revenue is not theirs. And it could have gone to someone else, some genuine source, but they've stolen it. So in this case, yeah, there's a fake ad engagement. And it's really low effort. If you're able to look at any, ad on your phone or in a browser, 99% of them, you'll see the tracking URL where you go to before you go to the website. You copy that tracking URL, you set up a little bot to just spam it. Hit that URL. And that's what these guys can do. And if they have some malware on the phone, they can scrape all of these tracking URLs and then just fire them whenever they want. And they just replace the small pieces of data. So they replace, a genuine source with my name. So Facebook with fake bot, and suddenly they're getting all the traffic. And this is the kind of thing we expect to see when we're looking at click spamming. So the blue is what we consider a normal or real user time to install. So we have time along the bottom, and we have number of attributions along the y-axis there. And so you see that it's a very sharp peak after about an hour with normal user behavior, but then with fake user behavior, it's very kind of random distribution there. It's very spread out, and that's what happens when people are just spamming you with fake data. The other one is click injection. It's kind of similar to click spamming in a way, whereas it's a real user who really wants to play your game, and all of the engagement, they go on, they play the levels, they spend money, that's all real. But the fake thing was that someone was monitoring their phone activity and waiting for them to download something from the Play Store or iTunes Store, and then they inject a click. So they still have that tracking URL, but it's very targeted. And to do that, they use malware. They can sense when something's being downloaded onto the phone. They look up the package IDs and they go, I know a tracking URL for that. And because it's malware, they can share it between all the phones that have the same malware on them. And this was in 2018, a huge amount of fraud went to this. And I'm sure it's still going on now for people that haven't protected themselves against it. And for this one, because it's in that very small window between when you're downloading an app and when you actually first open it, all of the install times in the pink here, which is fraud, is super early in the process, and then you see the normal distribution here. And that's click injection. And the final one is device spoofing and emulation. And in this case, pretty much everything is fake. One thing that people might do is, again, track the real traffic and then replay it at a later date. And that's what we'd consider spoofing. They take some data, they just replay it to try and get the credit. There's good ways of spotting this. You can check for SDK versions or whether the app is side-loaded or not. And if it's side-loaded, you can tell it's an emulation of a real device. And also, it's likely missing the predictable post-install activities. So when you're looking at spoofed activities, a lot of the time what you'll see is people that you can get an attribution for that user, but then they never play the game. They've never completed a level. They've never done anything in game that a normal user would do. And that's a really good way of detecting whether or not it was fraud. So yeah, the solutions to the dumb fraud are fairly trivial. So click spamming, you can look for frequency. If you get a lot of clicks from one user, you can pretty much say, that's click spamming. Click injection, you can look at the timestamps and work out whether or not it's too close together, or you can have a hard-coded time filter for that. And then the spoofing and emulation, add a checksum coming from the client, and then you can recreate it on the server and say, hey, yeah, they've got the right data. This is actually a valid install. It hasn't been replayed X months later, and they've just moved a few bits of data around because it won't work if you've got a checksum on that. And then we're fraud-free. Woohoo! No, we're not. So there's lots of other types of fraud. You might get IP address manipulation, so people appear like they're coming from one location or another, or you might get country mismatching, kind of similar to the IP address stuff, where you intend to serve an ad to someone in the US, but all of your installs come from China, or all from Russia, or you're paying a premium for a US install, but it's coming from anywhere else in the world, and that's a very clear type of fraud we see a lot of. And then the final one is this kind of distribution/intelligent spamming, where rather than hitting someone a lot, you spread it out. And you spread it out along with all of the other traffic. So it's not just fraud you're seeing. You're seeing 90% real traffic, 10% fraud. And if they hide it well inside that traffic, it's very hard to detect. Which is kind of where I wanted to talk about what we've tried to do to prevent this. So we had a bunch of clever data scientists here that said, hey, we think we can tackle this. And what we'll do is we'll look at a trustworthy source which doesn't have much fraud at all, like Facebook. Well done, guys. Let's trust Facebook with our data. Yes. And we did. So Facebook turned out to be very trustworthy when it comes to attribution and advertising. They do a lot of work themselves to prevent fraud. And so if we take their distribution, which is the blue line here, and we compare it to somebody else, this orange line here, you can see there's a huge distance in terms of what the normal trend would be. And I'm not going to bother trying to read all this stuff. You guys can digest that yourselves. The idea is basically to work out the distance and then work out the likelihood that that is a fraudulent transaction. And so we did this with a combination of our Java service and also using the wonderful power of MySQL. It's not quite as easy as just taking one data point, though. So you can't just take, I'm going to take the whole of Facebook and compare it to the whole of Twitter. Because it might not be the whole of one network which is fraudulent. You need to look at the different dimensions of data. And so in this case, we look at things like network being where the ad was served, the operating system, maybe the country, the site or publisher, and things like the campaign name. And this gives us a breakdown of how the different distributions might fit together and which campaigns or which sites or which publishers might be fraudulent. And so we built this system called ClickJudge. And from our attribution service, what happens is it puts all of these potential click matches onto Kafka, because that's what we do for our transport here. And it also means there's a bit of resilience and redundancy in the system. And then ClickJudge will process those. It takes the click matches and puts them in the database and then updates its scheduler. The scheduling part is very, very interesting. And whilst I don't have the full details here, effectively what it does is every time it sees one of these unique dimensions, it says, okay, I need to update this inside the next 5 seconds, let's say. Sorry, I previously should have mentioned, all of this is real time. So we would expect an attribution to happen sub-second on any click and install. So as soon as it happens, it will happen. So this, however, doesn't need to be fully real time because it just needs to calculate the difference. And because we're not looking for fraud on one single install, we're kind of looking for the pattern of how it's behaving. We don't have to schedule for every single match. We just have to schedule every half a second or so. And so it will update the scheduler, and then later on, it will calculate the deviation and give us a score. That score is then persisted in the database, and then we will make an RPC call to get the click matches. And we'll say, hey, for this click match, am I fraudulent? And it'll come back and say, okay, your score for this network says you're not fraudulent. It's pretty straightforward, but lesson learned number 2, measure twice, cut once. So I'm sure if any of you have ever done any DIY or done any design tech, people say, oh, you've got to measure that, measure it again before you make your move. And again, this is something that bit us in the arse, and we're very humble, and therefore we're sharing our faults with you so you don't have to make the same mistakes. we didn't calculate our data points properly. And so if we start with network, we probably have about 100 networks running at any one time. Okay, so that means 100 updates. If we're just looking at networks alone, that means 100 updates for any piece of fraud. But once you add OS in, that's going to almost double, Android and iOS, and then maybe got some Windows or maybe some Amazon devices. We hit about 250 uniques once you add that in. Then you add in country, and we get up to about 5,000 to 6,000 different combinations then. And then you add in site and publisher, and now you're hitting 450,000 different combinations that we have to account for. And I think that's probably when we went to sleep and said, job done. 450,000 different calculations, that's all we need to handle. So we scaled the system accordingly, we made sure our database queries were running properly, and we had enough database connections to be able to service all these requests and the updates that are coming in. But at some point, yeah, we fell asleep, and we must have missed a dimension, and I don't know which one it was. But when you run this all through, you run out about 4.5 million different updates / combinations over the course of a day. But these constantly need to be rescheduled and recalculated to make sure you're detecting the fraud. And so, yeah, measure twice, cut once. I think they could go for anything you're developing or anything you're investing in. Just take one more look at the problem domain before you jump in and try and solve it. And so what did we do? We took a step back, and then we went at it again. We sharded our databases. We refined the scheduler to be more flexible. And then we stuck with the rest of the process the way it was because it worked. And I knew I'd forget, and that's why I put this little orange box here. One of the kind of cool things about the way that we structured ClickJudge was that we made it so it's very easy for our data scientists to come along and plug in new fraud modules. So this was for one very specific case of looking at the deviation or the distribution of click-to-install times. Now, if they wanted to come along and model it in a slightly different way and compare models, or to do something completely different with a different data set, we made it so all they need to do is have implement one simple Java interface and then plug in the database that they want to use. And that enabled them, or will enable them, to go off and just develop whatever they want, and we shouldn't care. As long as they stick within our SLA for response times, they can do as many calculations as they want. And the fact that they can do it asynchronously because of Kafka means that the only piece we care about is returning the click match, and that's almost instant anyway. And then we really can party, because that does cover off the last chink in our armor. And I know I've absolutely rattled through this at a rate of knots, but this kind of whole project, the fraud piece, was a good year of my life, and I probably could have stood up here and gone into loads more detail. And so if you have any questions about that later, please ask me. And then last 4.5 years before that on the attribution piece. And it's not just the attribution piece that makes it interesting. It's all of the systems that go around it, which make it scalable, which is kind of cool. So that's it. I'm sorry it wasn't super technical, but I hope you enjoyed it anyway.